Lesson 6 talks about factoring conjugate pairs, and that's what we're going to do. That's actually factoring the difference of two squares, which in the lesson, they show something that looks like this. A squared minus b squared equals a plus b times a minus c. So you're actually going to have to recognize perfect square numbers. If you have two perfect square numbers being subtracted, then you can separate it into their square roots. The square root of a squared is a. The square root of b squared is b, and you'll have one adding and one subtracting. But before you do that, you're actually going to have to know your perfect squares, which I have right here. I apologize. So I actually gave the perfect squares. Let me start here. I gave the perfect squares, which are the numbers that are circled. Those are numbers that you get when you multiply a number by itself. 1 squared is 1, 2 squared is 4, 3 squared is 9. So I gave all the perfect squares up to 144, but perfect squares go on forever. And then I also gave perfect squares of variable terms. So if you notice, all perfect squares are even numbers. That's because when you're squaring a number, you're actually adding the exponents, or in this case, you're multiplying them. A power to a power gives you you multiply. So x to the first squared is you multiply the exponents. So I gave you a list of perfect squares, which you should memorize because they're not going to give them to you. So let's get right into an example. Here we have example 1. You have x squared minus 9. I know x squared is a perfect square. I know 9 is a perfect square. They're both on my list. So you have to ask yourself, what is the square root of x squared? In other words, what times itself gives you x squared? Well, the answer here is x to the first. And what times itself gives you 9? Well, the answer here is 3. So you're going to have two of them, but one's going to be positive and one's going to be negative. So your final answer will actually just be x plus 3, x minus 3. Next, we'll do example 2. And remember, you can only do this if it's the difference, meaning subtraction of two perfect squares. So we have to ask ourselves, are 4 and 81 perfect squares? Yup, they're on our list. Is x squared and y squared a perfect square? As long as the exponent of the variable is even, it is a perfect square. So what is the square root of 4? What number times itself gives you 4? That's 2. What times itself gives you x squared? That's x. What times itself gives you 81? That's 9. What times itself gives you y squared? That's y. So you'll have them twice. And just as this rule says, 1 plus, 1 minus. That's it. Let's look at two more examples. We have 25x squared minus 16. They're all perfect squares, 25 and 16. The square root of 25 is 5. The square root of x squared is x. The square root of 16 is 4. And again, 1 plus, 1 minus, or 1 minus, 1 plus. It really doesn't matter. And our last example. You see, we're getting to it a lot faster. 1 and 4x squared. 1 is a perfect square. It's right here. 4 is a perfect square. It's right here. And x squared is a perfect square because it's an even exponent. What times itself is 1? 1. What times itself is 4? 2. What times itself is x squared? X. 1 plus, 1 minus. So to factor out the difference of perfect squares, you just have to make sure that it's the subtraction of two perfect squares, and you just write their square roots. 1 plus, 1 minus. These are very important to memorize.